Lesson 7, Surds, Problem Solving. Example 7. Given that the perimeter of a tetrahedron is 12 centimeters, find the exact units of measurement, 1, its surface area, and 2, its volume. Now, part 1's fairly straightforward. First of all, we need to know what a tetrahedron looks like. That's a three-dimensional shape. So we'll have one side. Now this side is an equilateral triangle, all the sides are equal. Okay, it goes like that. So that equals that. Now, the perimeter is 12. Now, each of these edges here are equal, or side lengths. And there's a total of 1, 2, 3, 4, 5, 6. So the side lengths, or edges, is 6. So the length equals 12 divided by 6, which is 2 centimeters. So each of these are 2 centimeters. Now, if we take one of these faces and we drop it perpendicular down here, that's 1. So simply this height squared will be equal to 2 squared, hypotenuse squared, minus 1 squared. So h squared is equal to 3, so the height is the square root of 3. So the area is equal to half the base length, which is 2, times the height, which is root 3. So there we have the area of one face is equal to root 3 centimeters squared. Now, because all these faces are exactly the same, and there's 1, 2, 3, 4 of them, so there are 4 faces. So faces equals 4. Therefore, the surface area is equal to 4 times root 3, or 4 root 3 centimeters squared. Okay, the second part is volume. Now, this is a little bit trickier to work out. First of all, we've got our shape here. We need to find, I'll draw another colour here. We need that height. Alright, that's the main thing, to get the height. Because we know the volume of the pyramid, this is a pyramid, is a third times the base area times the height. Now we've got that base area. We've already worked it out. I'll write that down now. The area of the base to be called is square root of 3. Right. Now, so we're after the height. Now, what I'll do here, I'll need to get, if you take that line through here, so it'll drop down right in the middle. I need to find that distance there, because I've got this one here. We know that's 2. So what I've got there is, let's draw this over here. We've got that's 2. Alright, I need to find out what that is. So first of all, I've got to get that one there. Right, now what I'll do is I'll look at a plan of this. We'll go down on top. There's our equilateral triangle again. And we're going to go in here. Whoops. In here. And in here. Now, before I can get that side, I need to find out that little height of that triangle there. Now we know this is 2. How do we get that? Right, now it's really quite nice because that area is 1/3 of the total. So we know the area of this. So the area of this triangle is equal to root 3 on 3. Because that was the total area, remember? So this will be 1/3 of that. Now, the height of the area, root 3 on 3, is equal to the half times the base, which is 2 times the height. Of course, they cancel out. We just get the height is root 3 on 3 centimeters. Okay, so we've got that. We've got that height there. Remember, after this distance here. So we've got this one. Right. So this one is root 3 over 3. Just drop this down a bit. This one will be 1. This one up here. That's 1. So we need to find this distance here. Call this, say, x. Right, so we know that x squared will be root 3 on 3 squared plus 1 squared. Now, root 3 on 3 squared is going to be 3 on 9 plus 1, which is a third plus 1, which is 4/3. Therefore, x must be the square root of this, which is 2 over root 3. Right, so we've got that distance there. Now we're going back into the big triangle now, over here. So we're back up to, move this one up here. We're back up this one now. We've got that. There it is. We've got that bit there. So now we're almost there. Great application of Surds, this one. And that was 2 on root 3. Okay, 2 on root 3. Okay, here we go again with Pythagoras. H squared equals, so it'll be 2 squared minus 2 on root 3 all squared, which is 4 minus 4/3. Okay, and that's going to be equal to, now that's 4 3s are 12, minus 8, it's minus 4, 8 on 3. So H is equal to, sorry about that, H is equal to the square root of 8 on 3, which is going to be, that's going to be the square root of 8 on the square root of 3, which is 2 root 2 on the square root of 3. Right, now we've got the height. Now go back. Remember what the volume is a third the base area times the height. So the volume equals 1/3 the base area. Remember the root 3 times the height, 2 root 2 on root 3. These root 3's cancel out. And we get the final result of the volume being 2 root 2 on 3 units cubed. An excellent example of the exact value of the volume of a tetrahedron. You know, also, if you wanted to go through this and generalize that result, I'll leave you to do that one. So you've got a general formula for this, not too difficult. What you got to do is go from the start, instead of putting in 2, just make that an A and generate a formula.